Push that rock here with some math. Let's talk a little more about the frequency of periodic functions. So here I have a cosine wave, but the input is dilated. We have some kind of horizontal stretch or compression because the input is being divided by 2, which is the same thing, of course, as the input being multiplied by a half. Right? Multiplying a number by a half cuts it in half, same as dividing it into 2 parts. So I'm going to choose as my input pi. When I cut it in half, that becomes pi halves, and cosine of pi halves is, of course, 0. You know what? I forgot 0 again. So if I put in 0 and cut that in half, I still get 0, and cosine of pi of 0 becomes 1. Then when I put in 2 pi, cut that in half, it's 1 pi. Cosine of 1 pi is negative 1. When I put in 3 pi, it becomes 3 pi over 2 when I cut it in half, and cosine of 3 pi over 2 is back to 0. And 4 pi cut in half is, of course, 2 pi's, and cosine of 2 pi is back to 1. So let's use these points and graph the cosine wave. So when the input is 0, the output was 1. Input is 0, output is 1. Input is pi, output is 0. Input is 2 pi, output is a negative 1. Here's 2 pi, here's negative 1. Input is 3 pi, output is 0. And input is 4 pi, output is 1. Now, if you're a beginner, this might not be enough points. You might graph this wrong. It might look like a big V to you or something, but we're not beginners anymore. We've graphed a few cosine waves. We know that it kind of it stays close to 1 for a while before it drops down. Then it kind of drops down quickly to negative 1, then hugs negative 1. I went a little too low there, but hugs negative 1 and hits negative 1 right there. It gets close to negative 1 kind of quickly, and then it's getting closer, 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 hits negative 1, stays close to negative 1 for a while, then comes up. So it creates this curve shape is what I'm trying to do. It's a curve, and it looks like a wave, and in fact it's called a sinusoidal wave. This particular one is a cosine wave. Now notice that it finished its cycle. We know that it's going to continue the pattern, so we put 3 dots or 3 dashes to represent that the pattern will continue in both directions. But that's one cycle, and it finishes one cycle over 4 pi. So that means the period, or I should say least period maybe, least period, is 4 pi. Now the amplitude was unaffected, so the amplitude of a cosine wave is normally 1. See, from here to there is 1, and it's the same for this one. Okay, so that was unaffected, but the period did change. Normally the period is 2 pi. Well, how much of the cosine wave finished by 2 pi? Oh, half of it, right? There's half, and there's the other half. So I could fold this over, right, and it'd land perfectly on top of that. So half of the wave finished. Is that a coincidence that the coefficient is a half? No, and in fact, that's why they call that the frequency. The frequency here is 1/2, both because it's the coefficient on the input variable, but also because that's how frequent the graph is. The cycle is. Only half of the cycle finishes over its normal period. So that's the. Now, how would I get to this period if I didn't have it graphed? If I was just looking at this, well, you would take the normal period and divide it by the frequency coefficient. So the normal period is 2 pi, and I divide it by the frequency, which is 1/2. Oh, we have to remember that's 2 pi divided by 1/2, and dividing by half actually multiplies by 2 and gives us 4, right? So if I divide 2 pi by half, I end up with 4 pi, and that's the period of this form of the cosine wave when the input is x over 2. And we can see it there. It took a whole 4 pi and length of inputs that is 4 pi units long for it to finish its cycle. That's what makes the least period 4 pi in this particular case. It's normally 2 pi for just regular old y equals cosine of x. It's normally 2 pi, but for this one, 4 pi. Math made simple. Some math.